And I'm really excited to meet you all and to have this hour-long discussion about the technology that we're bringing into the Web3 world. And along with me today, I have my colleague from Syntropy, Emilis, and he will be monitoring all of the chats and your questions. I'd like for this to be as interactive as possible. It's it's not feasible to just open up everybody's audio and have people jump in ad hoc. So when you have questions, please post them in the chat, and Emilis will stop me and he'll get my attention and he'll ask the questions that come through the chat. Let me make sure that you guys can all hear me. Can some of you please type in the chat that so far so good? All right, awesome. One second here. All right, so this workshop, for lack of a better term, came out of something that I did internally for some of our folks here at Syntropy. And it was really just like a high-level overview of our technology and its value to our customers. And then Emilis said, "Hey, it would be great if you did a repeat of that with our community." So that's how this idea came to be. And I want it to be sort of free-flowing. To begin with, I'm assuming that many of you here are probably investors in our project or have been following it for some time and obviously have enough of an interest to be here. Y'all may have different levels of understanding in specific with regards to how our tech works. So I'm going to start at a little bit of a high level, and then I'll see what kinds of questions come up. But again, the goal is to sort of talk about what our tech does, why it's disruptive, how it fits into the Web3 world, and why our customers care, which is a pretty important question, because if you don't have customers, if you don't have adoption, then I'm not so sure that what you're doing has any tangibility. So let's see. I'm going to switch to a little bit of a whiteboard. All right. And right now I definitely cannot see the chat. So if something comes up, Emilis, please do interrupt me. Are you there on audio, Emilis?
All good, yeah.
Perfect, great. So in today's internet, which I have a background in starting in the 1990s, my first job was selling T1 connectivity to banks on Wall Street. And at the time, it was pretty funny because we were a T1 connection in the US is a 1.5 megabit per second connection. And it was shared for like everybody in the entire company. And we had to convince people that it was worthwhile to make this investment in having internet connectivity. We were saying things like, well, you can have email, you can have a web page. And believe it or not, some people used to say, oh, this is just a fad, it's going to go away. I like to tell that story because I think we're in a similar situation now with blockchain and with Web3. And although there are tens of thousands of projects, many of which will not survive the next bull bear cycle, similar to the dot-com boom and bust in 2000, I do think that this technology is absolutely here to stay. And what we're doing at Syntropy is different than a lot of the other blockchain projects out there, because we're not trying to create a cryptocurrency for the sake of a currency or even add smart contract programmability. What we're trying to do is decentralize telecommunications and have more influence over the performance that our applications require as they pass traffic over the global internet. Now, I should also mention that back in 2006, you can look me up on YouTube, I was working on a film project called Money the Movie. And it was about the evolution of the monetary system and social and society. And in it, we predicted the birth of cryptocurrency. We said, you know, someday where people are going to come together, they're going to create their own money system, they're going to use the internet to do it. It's going to be democratic. And I had the privilege of, at the time, meeting and spending time with the real pioneers of not crypto, but finance and local currency systems, and these ideas that we need to make some sort of a change to help society evolve. And from there, it led me into a project called Holochain. So I was involved in the early gatherings, hackathons of what then became Holochain. At the time, it wasn't called that. We were just trying to create a distributed ledger tech that would enable the creation of double accounting local currency systems. So I've been actually in the digital assets blockchain world for many years. And what's led me here to Syntropy is that because of my networking background and my blockchain background, I see that what we're doing here is sort of inevitable. And I've never seen anybody do anything like this before. So with that sort of page set, I'll mention that today, the way that traffic travels over the internet, whoops, my Apple Pen isn't working. All right. And I don't want orange, I want black. I might be stuck with orange for now. Let's see. No, okay, better. So today, the way that your house is connected to the internet, you've got some service provider who gives you that what we call the last mile. Now that could actually be 5G these days. It could be a modem. It could be fiber or DSL that comes into your house, but it's provided by some service provider. And that service provider has what we refer to in the industry as an autonomous system. It basically means that this company owns its own network infrastructure, however large that may be, and there's probably thousands or tens of thousands of sites. But then they have a large network made up of routers and other networking devices, and there are probably thousands or hundreds of these that can sometime, in the case of like an AT&T or a Verizon, span the entire world. But these service providers are in charge of the way that traffic moves within their own network. And they use what are known as routing protocols to advertise where the destination addresses are and to make what's known as a next hop decision. So when a packet comes into a router, the router looks into a database called an IP routing table, and it says, oh, where is this packet trying to go? All right, I know where to send it. And we've been using these technologies called routing protocols since the 80s. And although they were revolutionary at the time, we are kind of still living in a world with the intelligence of routing protocols that were designed many decades ago. Now, inside your own company, you use a specific kind of routing protocol that you have total control over. But when you're an internet service provider or a cloud provider or some large company and you want to connect to another large company, you want to connect your autonomous system to someone else's autonomous system, you don't want the mistakes that some other company's employee might make, excuse me, to impact your business. You don't want somebody else's mistake to have an effect on the routing tables inside your company's routers. So this idea of creating a different kind of routing protocol, technically speaking, it's called an exterior gateway protocol. If you've ever heard of the routing protocol BGP fits into this classification. It's an external routing protocol. And in addition to having a range of IP addresses that you own as a company or as a service provider, you're also given what's known as an AS number or an autonomous system number. And this is how we identify the entire conglomerate of networking equipment and devices and IP addresses that a given company may quote unquote own. These are managed centrally. I forget if it's the Internet Engineering Task Force or who it is. Bill Norton, who's on the call, could probably say who it is. But you have to apply, maybe it's IANA, or it used to be. You have to apply for these, and then you're given one of these AS numbers. Now, the way that these routing protocols work is they look for, like, what's the shortest number of ASs that I need to pass through to get to some given destination. So if I'm over here at site A, and I'm trying to get to site B, maybe I will change the color. Here's site A and here's site B. The routing protocol isn't intelligent enough to consider the bandwidth that's available, how congested the network might be, what kind of jitter or latency or packet loss we might be experiencing. The BGP routing protocol is just looking for what's the shortest quote unquote way there. Just like you would hope when you're driving to somebody's house, you're looking for what's the shortest path. But you know that sometimes you can get on the highway and actually experience unpredicted traffic or congestion. And that's where things like Waze or Google Maps comes in, because you can then find alternate paths. And it's become somewhat of a cliche, but we use that analogy a lot here at Syntropy, because what our tech ultimately does is it finds the fastest, highest performant path at any given time of the day across the global internet. And it sees this information in spite of the fact that underneath of it all, you've got all these different service providers who have their own business relationships. They have their own peering relationships. They have their own business drivers as to why they exchange data with another company at some place in the world. We usually call these points of presence or internet exchanges. Let me pause there just for a second and see if there are any questions. Emilis, I can't see the chat, so I'm counting on you to keep me updated.
Yeah, all good. No questions in terms of what you're talking at the moment. There was the question, in regards to how your day looks like at what you're doing. So you
How my
can
day looks?
answer. Yeah. Just how your work day looks. What are you doing, on a daily basis?
Oh, okay. Yeah, let me not get off tangent too far. Let me give you a short answer to that. Day to day at Syntropy, my responsibility is to show the value of what we do to customers, to walk them through the proof of concept phase, which any large company will always do, their lab, and then to close the business. So we call this a solutions architect or a sales engineer, and I work hand in hand. I work within the sales team. I work for Jeff LeCouture, who's the chief revenue officer, and our focus is entirely on proving and the value of what we do to and bringing in new customers.
Thank you.
And there's some go-to-market strategy that I participate in, and some thinking that I help to contribute to the senior leadership team from time to time, with regards to how we develop the product, because of course the feedback we get directly from our customers is what helps us to understand what new features we want to build into it in the future. And I'll probably do a quick demo of the tech in just a little bit later and show you what the DARP matrix looks like and the Syntropy Stack software if you haven't seen it before. All right, so I'm going to keep going on this path here and saying that the way the global internet works is that the companies that own the assets decide how they want to send traffic to each other. They usually do this at exchange points, data centers where they both have a presence, and they're able to they're able to pass traffic to each other, and they have some kind of business relationship whereby they redeem or provide each other with credits or have to pay each other at the end of the day or the month for, if I'm giving you a lot more traffic than you're giving me, then there may be an imbalance, and I'm going to need some type of a contract financially to balance out the fact that I'm passing traffic to your network. So these types of business relationships can be very complex, but ultimately they're in control of how the traffic travels through the global network. What we do at Syntropy, and Bill, who's on the call, is one of the co-founders and inventor of this technology, is we've created a new kind of routing protocol. Now, it's not the kind of routing protocol that we typically think of in the OSI model at layer 3, meaning it's not advertising IP networks and what the next hop is. What the DARP, which is the Distributed Autonomous Routing Protocol, what the DARP devices do, and we install these everywhere and anywhere on the global internet. So if it's an Amazon data center, or if it's a customer data center, or if it's a point of presence somewhere, or pretty much any service provider that we can get our hands on, in the world, and we've got hundreds of these nodes already deployed. These devices, you could call them relays, all right? They're operating at what we like to call layer 4, or the transport layer of the OSI model, and they're sending each other basically measurement data. So they're figuring out from any point in this network of DARP nodes to any other point, any other DARP node globally, what's the delay? How long is it taking for my packet to get to that other device? And if there are 500 DARP nodes, then I'm sending a packet to 499 other DARP nodes, and they're all doing the same. And then there's a process whereby, with all of this information, DARP is able to determine what the best path at any given time on the global internet will be to get between any two of these DARP nodes. The beauty in this is that if suddenly there's a failure in the service provider's physical infrastructure, or there's some type of congestion that intermittently appears, DARP is taking these measurements every 5 seconds. And in that amount of time, we're able to figure out, oh, that path is no longer as fast as we thought it was. And this is no matter what's going on underneath in all of these service providers' networks, all we really care about is what's going to serve us best at any given point in time. So one way to think about this is that we're kind of taking the best of every network in the world and creating this new internet from it. And because we are a Web3 driven project, these DARP nodes will eventually be run by people like you. And as our customers use the service and they pay for that service ideally in our Syntropy token, then some portion of that token proceed is paid to the operator who's actually managing and running that node that's doing the job of passing traffic. Now, I've kind of skipped a little bit of a point here because the DARP nodes themselves are an infrastructure that provides the measurements, and then you need another piece of software called a Syntropy agent. And in this little example, we would install the agent, let's say, I keep forgetting my pen's not working. Let's say over here on site A, I would install a Syntropy agent. And over here on site B, I would install a Syntropy agent. And then the Syntropy agent will take the original IP packet that it's generated, and then it will re-encapsulate it into another IP packet, which is called double encapsulation. And WireGuard, which is the mechanism we use for encryption and double encapsulation, it's an open standard. WireGuard encrypts the original IP packet as a payload, puts it into this new packet, and then points it to the DARP node that we see is going to provide the best path. This is how we override the underlying service provider's decision, because their default routing system may say, to get to this destination IP address, go to this next hop address. But because we've put it inside of another WireGuard encapsulated packet, and we've set the new destination IP to be the IP of the DARP node itself, we're able to get the traffic from point A to the DARP node, and then the DARP node will continue to forward that traffic along the path that the service provider enables to point B. And when the traffic is passing through one of these DARP nodes, it's transiting one of those nodes, there's a per gigabyte amount of data that's being tracked. And this is how the tokenomics of what we're doing here at Syntropy works, is that as our customers consume the service and pay for it, we are also able to incentivize and reward the operators in our network. And where there's a requirement for more capacity, more people can add DARP nodes, or organizations or partners of any kind. Is there a question, Emilis?
Yes, there's a question whether is encryption end-to-end or per hop.
Yes, the encryption is end-to-end. maybe this is a good time I can jump into some of the software. Excuse me.
So there's a question. It's encrypted whilst traversing through any intermediate nodes without re-encrypting and decrypting. Is that correct?
Yeah, that's correct. We don't. That would slow down things, right? If we had to decrypt it and re-encrypt it at every hop. So it's peer-to-peer encryption. So it's from agent to agent. The DARP nodes are not doing de-encryption and encryption. They're tunneling the traffic through. Okay, this is actually what we call an overlay, because by virtue of that double encapsulation, the outer IP, of course, isn't encapsulated, and it's what the DARP nodes and the other routers on the internet are using to get the packet to where it needs to go. And so the data that we originally encapsulate is just the payload, and it remains encrypted until it gets to its destination, and the WireGuard agent on the destination will de-encrypt the traffic. And we've chosen WireGuard because it's an open standard, and it's the fastest, lightest weight encryption mechanism. I'm not exactly sure what the numbers are these days, but sometimes it can only consume like maybe 1 or 2% of the CPU. And there are other VPN technologies that require a lot more processing power. And WireGuard has kind of like changed the game because it's much fewer lines of code, and it also is modular, and it enables the tech to keep up with new standards as they emerge. So as a new encryption algorithm becomes viable, and you don't have to replace WireGuard, you can replace the encryption module in WireGuard. I think I over-answered that question, but hopefully it got us where we wanted to go.
Perfect, clear.
So what we're looking at right now on the screen is a matrix of about 200 DARP nodes that are deployed globally. This set of nodes is listed both across the top and down the side of the screen. It's the same set of nodes. And if I zoom in, you can see there's some delineation. There's usually a name of a city, like Frankfurt, what network it's sitting on, in this case, Amazon. If I grab another one randomly here, this looks like it's in Romania, Bucharest. I don't know what M247 is, but I'm guessing that's some kind of cloud provider or service provider in Romania. Excuse me, for example. So these nodes are deployed all around the world. And on this chart, where there's a green dot, that means we've found a faster path than what the service provider sees as the default path. Where there's a white dot, we've not yet found a way to increase performance. So for example, this looks like Google in Brussels to Snell in the Netherlands, okay, which are not very far apart, by the way. The default path is 10 milliseconds, and we don't have a better path. So that's why it's white on the screen. But if I click on one of these green dots, this one is Zurich to Singapore. And it's coming from 9 Internet Solutions AG. That's either a service provider or a cloud provider, and going to DigitalOcean in Singapore. And the default routing path that the service providers would otherwise put this traffic on will take 260 milliseconds to get from Zurich to Singapore. If you use DARP, we can shave off 150 milliseconds and reduce the overall latency down to about 110 milliseconds. That's a very substantial improvement. That's about 40%. And I could click around and show you similar outputs anywhere on this map. This is actually a public link, so feel free to go to it and play around with it on your own. It's quite interesting sometimes to see, in this case, the better path from Zurich to Singapore is to go through a DARP node in Milan. And look, it actually just changed real quickly there. So you can see it's also dynamic in real time. What else was I going to say? Oh, yeah. What got me to leave, I used to work for Amazon Web Services before I came to Syntropy. What got me here was seeing this. When we looked at nodes that are deployed just on Amazon, and Amazon has its own global backbone, right? You guys all know that. They have a probably a multi-billion-dollar international backbone. And they promise customers that it's always going to be faster than the internet to take their backbone. Even on Amazon's own backbone, from some data, some region of Amazon to some other region, we find better paths on Amazon's own backbone, sometimes actually going over the global internet. In fact, there we go. So if I click on this, yep, to go from Tokyo Amazon to Cape Town, South Africa Amazon, the default path is 357 milliseconds. If you actually go from Tokyo to, it looks like MX Neil, which is a DARP node in Cape Town as well, it's in Melbourne. So if you go from Tokyo to Australia to Cape Town, with DARP, we can shave off 211 milliseconds, which is like 60%, right? And that's going from Amazon to Amazon. So that's really powerful, okay? And the value proposition, therefore, is for our customers is that large companies, large enterprises may often have their own data centers, meaning their own physical brick and mortar facilities, even if they rent them out, where they have servers, databases, applications basically running. And although we've seen a massive uptick in the trend of moving everything to the cloud, companies can't do that overnight. And the cloud is also very expensive. So most large companies in the world, unless they were quote unquote born in the cloud, like Uber or Pinterest, have some degree of data still sitting on their own bare metal, or they have mainframes. Think of all the banks in the world, or any kind of large enterprise that has for decades been developing their own custom applications. And some of this data is so sensitive, they don't want to put it on the cloud, or it's just too expensive to put in the cloud or too expensive to move to the cloud. So what ends up happening is that companies will use some services on a cloud like Amazon, and they'll keep some component of their application architecture on their own physical premises. And that means that that traffic needs to go between the private data center and the cloud. And that could be 10 miles, or it could be, I want to say 10,000 miles, but I don't think the circumference of the earth is even that large, or many thousands of miles. And in that case, the performance of the application is going to be dependent on how sufficiently the traffic moves between, let's say, the customer prem and the cloud. And also many enterprise, that means like large multi-billion-dollar customers, will have different business units, and those different business units might be using different cloud providers. Some of them might be using Azure, some of them might be using Amazon, and they may have data centers themselves all over the world. So those are the kinds of target customers that we look for. People who care about how well their applications are performing. And then also, there's another important use case, which is that when you don't have control over the path your traffic takes on the global internet, and something happens downstream from you, meaning it's not your service provider that you're paying to connect to, but it's some other autonomous system, 2-3 autonomous systems away, they do something that affects the performance of your traffic, By the time you even figure out what's going on, it's disappeared. It's an intermittent glitch, or maybe a line was taken out of service for some type of maintenance window. You can't even complain to your service provider about it. But the latency went from, let's say, 100 milliseconds to 1,000 milliseconds, which is 1 second. That's pretty much an outage for an application. We have customers that use Syntropy as an insurance plan, meaning they're allowing Syntropy to monitor the default internet path as well as the alternate Syntropy paths. And if we see a spike in the default internet path up to some threshold that they get to set, it will automatically switch the traffic to an alternate Syntropy path. And they, even if that path might have been a little bit slower than the default internet path, if the default internet path was 100 milliseconds and the Syntropy path was 150 milliseconds, and their default internet path goes up to 1,000 milliseconds, but the Syntropy path stays at 150 milliseconds, what would you do? I'll take the 150 millisecond path. Thank you. So there's somewhat of a disaster recovery sort of backup value to what we do here at Syntropy as well. Make sense?
Yes, and there are a few questions for you.
Mm-hmm.
So the first one is, are there any plans to allow other networking vendors to implement Syntropy Stack natively into their products?
Ooh, sorry, I just created a crazy
No
fractal
problem.
on the screen.
No problem.
Networking companies. That was right. Like the person who wrote that question, you mean like companies that manufacture networking equipment?
Networking vendors.
Networking vendors, like Cisco.
Yeah.
Right? Yes, we are there. There currently are no partnerships in place to that level, but we are beginning to inquire to the product development groups of those large companies to see if there is interest in building something like this into, just let's say, for example, a Juniper router, and whereby the customer can push a button and take advantage of the Syntropy network. So yeah, we would hope to obtain those kinds of partnerships in the future. Where we're targeting more today are twofold. Companies that provide something called SD-WAN. SD-WAN is a solution that is proprietary in most cases, and it's a very competitive landscape. There are a number of multi-billion-dollar companies that, including Cisco, that provide what are known as SD-WAN solutions. And the thing about the SD-WAN solutions, however, is that those companies have to build their own infrastructure, and they don't have the benefit of the kind of Web3 scale that we have here at Syntropy, because we don't only always have to invest in DARP nodes to build out our network, because it's a community effort, right? So because of the decentralized nature of what we're doing, as this bandwidth marketplace matures, where there is a need for capacity and where there are strategic locations that would end up tunneling our traffic or passing our traffic through, then people will automatically want to put nodes in those locations because they're going to get paid to do it. And the idea is they'll get paid more to do it than it costs them to run that node. So SD-WAN companies generally don't have that advantage. They have to buy, own, and operate everything that they do on their own. Plus, their solutions are typically proprietary. They're not open source. So we can partner, and we're talking to a few SD-WAN companies now to add Syntropy Stack into what they're doing. And we're also talking to, in proof of concept stages, with companies that have points of presence, data centers around the world, where we see benefit to adding more paths, right? So there are strategic locations in Asia, maybe North Africa, parts of Europe, where there's not currently enough internet peering going on for the global internet, and there's a lot of congestion. And we've been finding the tier 2 and tier 3 service providers who have data centers that provide peering exchanges between other service providers in those regions that are sort of off the beaten track, right? They're in locations where if we put in a DARP node, we're going to see significant flow of traffic through that path because it's going to offer a better path. So those are some of the partnerships that we are forming.
Nice, thank you. And there's another question. Would companies on Wall Street be interested in DARP as it can speed up trading?
Yeah, high performance trading, what wins that game is nanoseconds, billionths of a second. So no, I don't think so, because someone who's doing high performance trading, a Wall Street firm, they're going to have their servers very closely located to the stock exchange, and they're gonna put in the fastest fiber. They're going to use the fastest servers humanly possible. They're going to buy switches from companies like Cisco and Arista and Juniper that are specifically built to provide even lower latency as the traffic passes through that physical box, down to the billionth of a second. So that's not really a target. I would say that any application that is impacted by latency, like a shopping cart, clearly gaming, ride share applications, anything that you're gonna, you want to open up your phone and you don't want to sit there waiting for a page to load. I see the metaverse as probably the next big growth area, meaning I don't know what the statistics are on the amounts of data that we're seeing on the global internet today, but whatever that is, times 10, right? As we move into these next 5 to 10 years, the metaverse, and I recommend reading the Medium article by Tony Parisi on how he defines the metaverse. But the metaverse includes Web 2 technology and Web 3 technology. It includes VR, it includes gaming, it includes virtual worlds, it includes web pages, it includes everything. But most of that, all of that stuff is going to be very interactive. So any kind of voice, video streaming that's time sensitive is a real, real good fit for what we're doing. So our targets are more and more becoming the Web3 companies that are building those type of applications. So blockchain gaming and metaverse type organizations, which I think are going to overshadow the amount of data we currently see on the global internet that we could call Web 2 data. I think that blockchain and metaverse data is going to become the big kid in town in the next 5 to 10 years. All right.
Thank you. We can move on.
Yeah, I see another question. I found a report that showed something like 50 milliseconds of latency would cost high volume trading companies millions of money a year in losses. I could be wrong, all right? But so far, I don't think that Wall Street high performance trading organizations are a good fit for what we do. Is it possible for Syntropy to extend its network by using some decentralized cloud computing network? Yeah, can you say more about that, Wen?
It's actually Wen Coinbase. It's not a name.
Is it a person?
Yeah, it's a person.
So I don't know exactly what you mean by that question. So there are, for example, I mentioned the project that I was involved in early on called Holochain. Holochain is a decentralized compute and hosting infrastructure. There's IPFS, of course, which is a distributed storage infrastructure. And what are emerging are more distributed cloud computing and distributed content distribution networks. Yeah, there are probably many applications for Syntropy on the roadmap in the future. Right now, we really want to bootstrap and sort of jumpstart this initial offering, which we have built and works. right? It's on the truck, so to speak, which is we can reduce your latency and give you better performance by continuously monitoring the path of traffic over the performance of traffic over the global internet and giving your routers locally the information they need to put the traffic out on the fastest path possible.
There's a longer question by Slenderman.
I see it. Is there any interest to form a central data network hub specifically based on Syntropy's routing tech to connect all ISPs, data centers, etc. together? Wasn't sure if that's what you already mentioned, to use all the autonomous systems, so ultimately you deploy an immense amount of DARP nodes on all possible networks and create one big mesh. We've done that. That is the plan of networks with all default benefits that Syntropy provides. Perhaps even in pulse groups or something. Well, you're really you're really on the nose with that. Bill, one of our co-founders, who I think is still on this meeting with us, has developed the next generation of the DARP routing protocol that is meant to scale to the tens of thousands. And it does use pulse groups as a mechanism for processing all of the information that an infrastructure of that size would provide. I don't know if any of you guys have ever looked into what like distributed hash tables do, but they use a similar kind of approach where you distribute the destination, the addresses in a distributed hash table, so that not every device has to maintain the entire superset of all possible paths in the network, but you still have the ability to discover any destination and figure out how to get to it. So it's a little bit of a parallel topic. The new DARP technology, which I believe we just got a patent on, is meant to facilitate scaling to tens of thousands of nodes. And yes, if we execute correctly, we should gain more and more interest from actual service providers to run the DARP technology themselves. In which case, you may end up with a global internet that's running DARP. And DARP is open source technology. So although we have a patent on it to protect it from trolls, anybody could use it. So sky's the limit on where that could go. If we get to that tipping point where this really does become sort of a de facto standard on the internet, I think sky's the limit for what we're doing. Is it possible to restart with the presentation for late people like me? I think we recorded this.
Yep, that's true.
This presentation makes me want to mortgage my house to buy more Noia. Haha, that's funny. This is not, this is a joke, right? Every time you watch something on YouTube, this is not financial advice. I wouldn't recommend mortgaging your house to buy more Noia, but we obviously believe very passionately in what we're doing here. Never invest more than you could afford to lose, is what I hear financial people telling me.
And it's true.
Yeah, it is. These markets are incredibly volatile. How's the market looking today? Is Bitcoin up or down?
Still volatile.
Scary times. What other questions?
Not many, actually. I'm just looking if we didn't answer any. Tim, do you have more time to go, for example, through Syntropy Stack agent presentation, or?
Yeah, let me see. My bookmarks, I had to use an alternate computer this morning. Are you guys seeing this?
Yes.
All right, so here I am. I'm logged into a demo account of Syntropy Stack. I'm also getting another cup of coffee. And this is the software that we've developed, which is currently needed to configure the relationship from those agents that I described earlier, are point-to-point VPN connections. And this is different than the DARP infrastructure that I showed you guys earlier. The DARP infrastructure is what we rely upon, what we need to provide those faster paths, but there's no DARP here in Syntropy Stack. Customers of ours do not need to install DARP nodes to take advantage of our service. What they do need to do is to get an account with this software that we call Stack, Syntropy Stack, and they log into it, and then they use this software to add endpoints. And they do that simply by saying add an endpoint, and they get a token, which is a private key. And we don't save that private key in the software or anywhere. We tell the customer this is, the only time you're going to see it, write it down, save it somewhere safe. And then they install like I said, guys, I unfortunately don't have my typical computer. But what I was going to show you is that you just run a couple of commands on the command line. You use what's known as Docker, and you install the agent using that private key that we provide to you in Stack. And then assuming that that agent is installed on the device successfully and it has internet connectivity, it will then talk to Stack automatically. And it will show up as an endpoint in this map. Once Stack sees that endpoint, right, we then choose which endpoints we want to talk to which other endpoints. If we don't specifically enable a connection between two endpoints, then they can't talk to each other, which is a powerful security model, by the way. It's called whitelisting, and it means nothing can talk to anything unless it's explicitly permitted. And this is the security model that we'll probably move into the future everywhere with. In the past, we've spent a lot of time and energy building firewalls and what are called access lists to control what traffic is allowed to talk, what devices are allowed to talk on what ports. It's very difficult to maintain and keep up with all the changing information and all the different applications. Instead, going to a model where you say nothing is allowed to talk to anything unless it's explicitly permitted means if somebody tries to hack, if they try to log into one of these endpoints and they're not coming from the other enabled endpoint, they won't be able to communicate with it. It'll just drop it. It'll ignore it. Now, when you enable one of these connections, and you can do so, using the software here, and you say, enable SDN, and this connection probably won't come up because it looks like one of these devices may be down. I just click a couple of buttons, and a link eventually comes up, and it gives me analytics. Looks like somebody, oh, there we go. All right. So like over the last hour, I can see that between Helsinki and Saudi Arabia, the default internet path is gray here on this timeline. It's providing 112. Well, this is stored in what we call a time series database, right? So at this specific time, looks like 4:19 p.m. March 10th. The public path was 125 milliseconds, and the three alternate paths that Syntropy is monitoring, one of them goes as low as 108. Now, that may not be a significant enough performance increase to warrant rerouting your traffic, but Stack is basically keeping track over time of how all of those paths are performing. And you'll see sometimes that the default internet path is good. It's chugging along. and then all of a sudden it spikes for 15 or 20 minutes. And that's when having one of these alternate paths can really save the application's performance. What else is in here that's interesting? I don't want to get too nerdy, but there's an ability to program the thresholds of by when these routing events should occur, like what performance increase are we looking for before we're going to reroute the traffic. There's the ability to save this configuration as code so that you don't have to do all the manual work in the future again. You can just upload a text file, either YAML or Terraform in the future, to rebuild your custom configuration. And eventually this config will be stored in some type of a smart contract, or a smart contract that has a pointer to some IPFS-like text file on the internet, so that customers will actually have to engage with the blockchain. And in fact, they may not even need Syntropy software to configure their network in the future if they know how to write their own smart contracts. All right. Please get nerdy.
Plenty of messages. Yeah, people want you to get nerdy, and they're also fired up about your DJ set that you have.
Yeah, meet us in Miami. We're going to be at the Miami Bitcoin conference the week of April 6th through 9. I think Syntropy's having a party there. And I think I'll probably be opening for one of the big DJs we've got. I've had a side career as a musician and a DJ. It's really just something I do for fun these days, but I love doing it.
Nice. There's one question by JP. You can see it, the long one.
How will DARP interface with other Web3 protocols at the transport network layers, and to what degree is it critical to DARP being adopted? ODAP. No, I'm going to write that down. Yeah. I don't know about ODAP. I should. Bill Norton might. One of our advisors, by the way, his name is Jeff Tansura. He's the chair of the routing committee at the IETF. So he's the guy who sits atop of the committee that writes the specifications for new routing protocols. And he's one of our advisors, and he probably knows a lot more about that than I do. With respect to, this is an interesting topic, Web3 protocols, right? Because blockchains have their own security. You could really, if you're talking about the OSI model, then there's what we call 7 layers of the OSI model. Okay, layer 1 is the physical connectivity. Layer 2 is like Ethernet encoding. Layer 3 is IP, right? This is where IP lives. Layer 4 is what we call transport, which is where kind of DARP lives. And then 5, 6, and 7, we generally lump into what we call the application layer. And really, layer 7 is the application. Blockchains are layer 7, right? Like they are an application that is relying upon the rest of the physical and IP infrastructure to get messages between validators or miners or what have you. As such, and one of the key distinctions of blockchain is that the consensus mechanism provides the security for that system, for that protocol. Now, in blockchain, we call things layer 1, layer 2, layer 3, but they're not related to the OSI model. What they mean by that, layer 1, is like it's actually the fundamental system like Bitcoin that is the protocol that provides not only the distributed ledger and the transaction capability, the inability to double spend, but the physical security, the protocol security. So most Web3 projects today are using libp2p, which I think came out of IPFS community. And it's a distributed hash table stack that is modularized, and a lot of different blockchain projects use libp2p for their networking layer. And again, because the security is already built in to the blockchain protocol at layer 7, there's no need to do additional encryption. So the VPN stuff that we do, peer-to-peer VPN, it makes a lot of sense right now with our enterprise customers. But as we begin doing more with Web3 projects like blockchains themselves, because you would say to yourself, well, if I'm Solana and I've got 10,000 validators on the global internet, wouldn't I benefit from using Syntropy? The answer is yes. You could increase the transactions per second by providing better paths between all of those validators. But they're not going to want the additional encryption. So we're working on a project now that will build libp2p into DARP so that the Web3 community can more easily consume DARP as an open standard in their Web3 projects without having to do the VPN piece. And it'll be an interface essentially between the DARP IP, the transport layer and IP routing system that provides best path, and it'll feed that information into the protocol, into the layer 1 project. And our vision is that if enough layer 1 projects are doing this, then in fact, they might even consider running DARP nodes themselves on the validators or alongside them. And we can additionally build this sort of DARP network globally. And so it may become a mechanism for not bridging the protocols, but at least interrelating different layer 1 projects on the same transport network. All right, guys. Well, I think our time is up.
Yeah, there's one more, maybe,
Yeah?
for
All right,
the
I'll do
Andrew.
it. Is it fair to say that DARP will ultimately replace MPLS? I could never go so far as to say that. Although there are some similarities between what MPLS is doing and DARP, they're really very different technologies. And I think for as long as service providers control their own networks and need to traffic engineer those networks, they're not going to move away from MPLS. But we're not competing with MPLS either, because if MPLS is running underneath DARP and it happens to be facilitating a faster path that DARP is able to recognize, we'll just send the traffic over that path in the network, right? So let MPLS do what it does best. Let all service providers try to provide the fastest paths they can, and let DARP always take advantage of the best of every global network and build a sort of more intelligent, more interconnected network with DARP across all service providers and cloud providers. All right, guys, thank you very much. It's been a pleasure. Reach out to Emilis if you have any follow-up questions or comments. And I'm happy to do this again in the future. So it's good meeting you all. Take care.
Thank you, Tim.